फील्ड के बारे में स्टडी कर रहे हैं। अभी तक हम लोगों ने यूटीएम से यूनिवर्सल टेस्टिंग मशीन में टेस्ट स्पेसिमेन के कौन कौन से प्रॉपर्टीज को टेंसाइल टेस्ट के द्वारा प्राप्त करते हैं, जैसे कि यील्ड स्ट्रेस, अल्टीमेट टेंसाइल स्ट्रेस एंड इलांगेशन इत्यादि के बारे में हम लोग डिटर्मिनेशन बेस्ड अपॉन द टेंसाइल टेस्ट रिजल्ट करते हैं। अभी IS 1786 और IS 1 it is given in Newton per mm square. So yield stress minimum of free bar of different grade is already given in the its grade itself. If it is Fe415, the minimum yield stress should be 415 Newton per mm square. 415 Newton per mm square. For 415D, it is also minimum 415 Newton per mm square. Fe500, it should be 500 Newton per mm square. For Fe500D, it should be 500 Newton per mm square. 550, it should be 550 Newton per mm square. 550D, 550 Newton per mm square, and 600 Newton per mm square. And percentage elongation minimum, this is also percentage elongation minimum. For Fe415, it should be 14.5%. For Fe415D, it is 18%. For Fe500, it is 12%. For Fe500D, it is more elongated, so 16%. For Fe550, it is 10%. And for 550D, elongation should be 14.5%. And for Fe600, it is 10%. Ultimate tensile strength. UTS, it is also minimum, and unit is Newton per mm square. So for Fe415, it should be 485 Newton per mm square. For Fe415D, it is 500 Newton per mm square. For Fe500, it is 545 Newton per mm square. For 500D, it is 565 Newton per mm square. For 550, it should be 585 Newton per mm square. For Fe550D, it should be 600 Newton per mm square. And for Fe600, it should be 660 Newton per mm square. This is one criteria. Yield stress should be 415. So for Fe415, ultimate tensile stress should be 485 minimum. But it is also guided by another criteria. It should be 10% more. It should be more than 10% yield stress. But minimum should be, if we find out yield stress, say it is of a test specimen yield stress, we find out it is 435. So minimum ultimate tensile strength should be plus 10%, say 43.5. So 5.5, 8, 7, 478.5. But it is in 485. So we should go for the 485. Likewise, it should be 10% more than the yield stress. It should be 12% more than the yield stress. It should be 8% more than the yield stress. Then it should be 6% more than the yield stress. It should 10% more than the yield stress, it should be 6% more than the yield stress, and it should be 8% more than the yield stress. So whatever yield stress we find out, we determine 10% of that. I did find out what is the UTS required. If it is less than coming say 475, so we have to go 485. If it is coming more than the material is more having more strength, say we got about 460. So 460 plus 46%, we take 6. So it is 506 Newton per mm square. In case of yield stress is coming 460, so we should get the ultimate tensile strength of that rebar as a 506 Newton per mm square uh, to be within the specification limit. Temperature generally carried out at room temperature, and which should be 10 degree centigrade to 35 degree centigrade, and controlled temperature if it is not specified. In certain cases, in the hot weather, the test specimen is also conditioned at for half an hour at 100 degree centigrade. So depending upon the client requirement, but if it is not specified in the code, it is given 10 degree centigrade to 35 degree centigrade room temperature should be maintained. If it is written in the controlled environment, it is for the controlled temperature, controlled environment, it should be 23 degree centigrade. So for the control for controlled environment, the temperature should be maintained in the laboratory to the 23 degree centigrade. If client requires, the test should be carried out in the controlled environment. So temperature should be 23 degree centigrade. Gauge length. It is proportional gauge length for all diameter bar. It is a gauge length is universally acceptable gauge length is given. That is gauge length. Gauge length is given by K root S, where K is proportional coefficient of proportionality. K is coefficient of proportionality. S is the cross sectional area of the specimen. So gauge length gauge length is 5.65 root of area of cross section of a specimen. So if a specimen is more than 4 mm to 32 mm, we go with the 4.65 root cross sectional area. If it is very thin, then we can go for, instead of 5.65, we can take 11.3. And a specimen minimum length of the specimen should be minimum length. If we have to select the minimum length, how much is the minimum length of specimen required for the testing? So we should have the gauge length equivalent to 5.65 root A root S, जो भी area का section है. Then there should be if this is a grip in the tensile stress, this should be root of S0 and root of S0. Say in case of we take 20 mm dia bar, so 20 mm dia bar gauge length will be say 100 mm. Then area square root of area will be about 17 mm. So this length will be about 17 mm, and this will be also 17 mm. So specimen size will be about 100 plus 34. So 134 required for the from grip to grip, and if grip is required say about 25 mm, so both side grip will be 75 150 mm grip, and grip will be 100 mm. So minimum area of rebar will be required of 234 mm length for the testing. So with the gauge length, if uh, we are testing raw material without gauge length, so it should be again proportionated to the gauge length for find out the elongation of the material. Yet if the material fractures outside the gauge length, if material fractures outside the gauge length, say here, then retesting should be done of the material. This should